Hi, everyone, and welcome to the last talk in our session on web and education track. And here with us is Jerônimo from Brazil. And I guess the internet connection sometimes is not super fancy, but the sound and the slides show all right. So Jerônimo will talk about how to make the math lessons better, and I guess he would introduce himself a bit more. So with this, I'm switching off. Jerônimo, the
Okay.
stage is yours.
Thanks, Levik, and thanks everyone from PyCon Sweden. It's really a pleasure to be here from another continent and talk a little bit of our experience here with Python and math. And talking about the subject today, now Slavik already told a little bit. We are going to talk about mathematics and Python. The title itself says a lot, much more than Bhaskara, how to use Python to create better math lessons. And my name is Jerônimo, and this is part of my dissertation for my master's in mathematical education. So a lot of this content is have ideas from my uh, master's advisor, Rosane. That's the second author right there. So let's dig in. And the first idea is that really like the idea of unconference, not the conference itself. So you guys, most of you have the Slack channel of the Python conference, and you also have the chat box on the YouTube transmission. I won't be seeing at this moment because I'm in the streaming interface the questions, but Slavik can send me in the end of the presentation. But the idea is that I'm here just to host the talk, but I'm not the master of knowledge in this subject. So if you guys come, you are in the right place, you are the right people, and what you have to say is the right thing to be said. There is no stupid questions. Be free to say anything at any time. We will probably answer most of the questions in the end of the talk, okay? And after it, even. So, what is this talk really about? Well, the thing is that I really love math, and quite intriguing because I have failed calculus in my first attempt at university like 3 times. But still, I love math. I think that math is one of the main subjects that any person needs to learn to really understand the world. As we see today, we have so many people that don't understand how things work because they don't really understand what is math, what it contributes to them. And I even made the choice of doing a master's in education, mathematical education, because I want to go deeper in this area to really try to understand what makes people so resistant to learning math and how we can change that scenario. And when I say I love math, most people are like, "What? What are you saying? Why are you saying that? You must be crazy. That thing, it really doesn't work." So I will add a little context to why I think that everyone loves math. Not only me, but everyone really loves math. Sometimes they just don't understand it on, or they don't see it, and what technology really has to do with teaching math in a better way. So, as I said before, this is part of the dissertation of my dissertation for a master's degree. I'm studying at UFPel. That's where also where I work. I work with distance education. So, as you have guessed, with the pandemic, we are having a lot of work too. And one of the master programs that we have here is the PPGE Match, which would be translated as a program of post-graduation in mathematical education, and it's focused not only in technology. My field is technology because I have graduated in the area. I have degree in market and system development, uh, and I love the area. But we also have a lot to do with understanding the traditional mathematical education. So it's really interesting that you can't talk about technology without understanding the context. And in my opinion, we have a really interesting context when we talk about Brazil. And when we say Brazil, just to clear a little bit, we are in the south of Brazil, here in Pelotas, almost at the border with Uruguay. And when we talk about Brazil, I think that most people think about football. It's also the state here that we are in. It's the same state as Ronaldinho Gaúcho, one of our most famous athletes. Although he's retired, he's always on the news here. And Brazil is also very known about our music. We can see that we have samba, we have carnival, we have funk. So it's like one of the two main topics when you talk about Brazil. But besides politics, that nowadays everyone is talking about, uh, one of the main subjects that we really are discussing and talking about almost every day. My wife also works with education. She's from the pedagogic field of study, so it's really common to that we talk about education, and especially in my case about math education. I think that most of the country is worried about if we are really being able to teach our children and our students, and even at university level, as we should have been teaching them. And unfortunately, the answer is no. Most of the indicators, like PISA, show that Brazil has stagnated in the performance of our students. And that's when we talk about general education, about all the fields of study, but especially when we go to talk about mathematical education, it gets worse. Unfortunately, we are seeing that we have a very low performance, especially in the mathematical area, and below the average performance of countries that should have a similar performance to us in related fields, such as country size and uh, the PIB and other indicators that should um, should aid us to compare. So we are like, what are we doing with our education? And it's really interesting and important to talk about this, because if we don't have math education now, in a few years, most of the news outlets and research indicate that we might not have jobs, we might not have a good economy to support our country, because math skills are needed in every job of the future. When we talk about programming, when we talk about data science, when we talk about statistics, when we talk about economy, if you don't have mathematics, oh, AI, we can't not talk about AI also. If you don't have math, you won't have a future in any of those fields. We are going to a world where almost everything is automated. So it's really complicated that we don't have this kind of structure by now. So I really think that Brazil is going to have to run to catch the development of other countries in this area, because it's essential to the future of our country. Maybe one of the most essential things to assure that we can support our people. And to understand a little better, there are research that indicate that around 50% of higher ed students that are using distance education drop out of their courses. And a lot of the students here in Brazil are in the public educational system, even in higher ed. And another research says that about the average cost to the taxpayers for each of those university students that drop out of their course is about 15,000 reais. And just to understand how big this sum is, our minimum wage is about 1,000 reais. So if we do a little math, we get like it's 15 times what we would pay just the minimum wage for someone. We could support them for almost 1 year and a quarter. And so that's really hard to it's shocking to see that we are living a third world country with not a lot of resource, with economy each time more complicated, and we don't really have a structure around education that supports our children and even higher ed. So I guess what I'm saying is better represented in this saying from Seth Godin in his short book "Stop Stealing Greens: What is School For," which is a book that I recommend for everyone that is in the education field. Although Seth Godin is from the marketing area, the way he writes is very interesting to make us think about what's the future of our education. And so he says, the economy has changed, possibly forever. The school hasn't changed. And this is interesting because we are talking in a context where in the last decade or even the last century, with technology evolving, with computers, with mobile phones, with even if we go way far, the industrial revolution, it has changed almost all uh, all the things in our lives. We don't communicate in the same way we used to communicate. We don't live as we used to live, but still we are learning as we used to learn. And I think that's something that we got to change. But when we say about math, what we are really saying, what is the way we learn? Well, I can share my experience, especially in the higher ed, that I think that's the most complicated. I think that basic education still has problems, but a lot of people are trying to change. But in higher ed, I can say that mathematical education is about books and more books and a lot of equations and exercise. I remember the first time that I had a calculus course, I had, I think, that 200 or 100 exercises of each topic of this area. And it was really overwhelming, and you don't really understand. It's like you repeat, 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 but what is X, what you are doing, why you are doing that? And I really like to make a little joke here that I think that people are um, mistakenly think that mathematics is like going to the gym. You go, you do like 10,000 repetitions, and your brain will get more muscular, will get more effective. And I really don't think that's the case. Of course, there are things that we really understand by repetition, but not everything. I think that using the context, and especially in this case that we are talking now, using technology itself is essential to learn math in an effective way. So, why students don't understand math in the traditional system? First of all, we have to go deeper in the traditional system. The traditional system, as we have said before, it has been that way even much before than all much of us that are living today. Like when we first introduce technology, people really have trouble, like Homer, like to start press any key and you don't understand that any key is like really any key. And when I say that we aren't using technology, we are really not understanding that we have so much to say, so much to use, so much uh, to make the experience of learning so deeper and so meaningful to the student, and we are still doing the same thing that we did 10, 20, 30 years before. Like one of the main examples that I love to say, here in Brazil, almost always when you are like finishing high school, we study physics and mathematics, and there is always a problem of train A going from the station A to point B, and train B going from the station B to the point A. Like they are going to cross each other at some point. But the reality is, most students don't even learn what a train is besides from a movie or something like that, because here in Brazil it's not really popular as a means of transportation. And also you don't really think how important this is. Like sometimes even people like in this animation think that the trains are going to collide, not that they are just going to do the same route. And so we think, what can we do to make this better? In my opinion, we can understand what our students living and what is important to them, what they interact at every moment. And in the first idea that I have is, oh, let's talk about games. I love games, although I'm quite a little bit older. I'm still a Street Fighter fan, and I have to use Street Fighter as an example because it really is mathematics. It's almost everyone think it's about mashing buttons and things like that, but when you see top players really playing the game, they have understand the game at some point. They have what they call the frame data, that they understand how much time each move set from the each character takes time to be performed, so they can counter react with a better move. And that's really interesting because you have to understand math to do that. You can't really just, oh, I press this button and it will solve. No, it's like every character has about 40 to 50 movements if you count every possibility of attack and movement itself. And so you have it's like chess but with better graphics. And that's really interesting because it's all math. No one, almost no one thinks like that, but it takes a lot of calculation for those who play it and for those who created it. And even it feels a little bit complex if we say like that, but it's not really unlike a game of rock paper scissors. It's like you have an opponent, you have three options in the rock paper scissors. In the in a fighting game, you have a little bit more than 50 options, and you have to calculate at each moment which is the best option in this in the range of the actions you can take at that moment. And also, another idea that I love to talk about when you are talking about mathematics and technology, I think that here in Brazil it's usually referred to as the Bhaskara equation, but in almost all the world we see that it has the quadratic equation, which is a really simple equation that everyone thinks that it is useless, at least here in Brazil. And we can see the graphic that a quadratic equation can be described as, and we don't see why we need to learn it. But if we try to use a little bit of context, we might understand it before we might understand it better. So in this example we are using a jump from a bmx event, and we are seeing that the exact same graphic that we have seen before as a quadratic equation graphic is the same graphic as the movement made by the biker. And we say, okay, you are now connecting to the reality, but this is physics. It has to do with movement, and he has practiced this movement a lot of times. He doesn't really need to know the equation to do that jump. You might be right, but the idea is that this equation connects to almost every type of jump because of gravity, of course, and it connects to almost every jump in digital games, which is something that everyone else is playing. I love the example of Mario because everyone has played Mario, and Mario in especially the older games really had a quadratic equation or something like that to simulate the jump. We see now that sometimes you have a lot of jumps in games that don't really respect the gravity, but the main idea is that if you don't know how math works, you can't really program or simulate an action that should feel real. So the idea is that you need to understand mathematics to understand the world, and it's beyond just gaming subjects. I love games, but math goes to a whole set of activities. Like we can talk about music and even use mathematical equations to create music, to create sounds, and to understand music itself. We are going to talk a little bit more about that when you talk about Sonic Pi. But the main idea is that you can't be a musician that is successful and have really don't have really a good math base. You can instinctive use math, but if you don't have math, you won't be a good musician. And other thing that you can't really disconnect from math is sports. Like everything that we do with the trajectory of a ball, let's say in basketball, has to do with physics and one more time quadratic equation. So, okay, now you convince me. I know math everywhere that I look around now. There is math. I recognize that math is really important. What can we do next? What are the issues of using technology to teach math in a better way? Well, first, when we say that we are going to use technology to teach math, it's really complicated because people just want something like Wolfram Alpha, that you put an equation, you say solve it, and it solves to you. But are you really learning math like that? I don't think so. I think that you are using a tool. And there is another problem. Wolfram Alpha has a lot of resources that you can use, but it's a closed software. And like MATLAB, that is really popular here in Brazil, you have to pay to use this kind of software. And nowadays, with our economy being a little bit off the tracks, like if you see the education prices of MATLAB and get to know what are your our exchange rates for the dollar, you think that, oh, it's really expensive. So we can't really my opinion is that no, we can't rely on closed software, on paying for software or hardware that we can't modify, we can't understand. And even I can uh, go a little bit on the history of math and think about the Skinner box. I think that's the main idea when we talk about technology. Why it's really old. Some of you might remember who Skinner was. Well, Skinner was one of the main behavioral psychologists that surfaced in the last century, and he also had this creation that was really simple at the time, but was one of the main pieces of technology that we can say that's modern. That's like the idea that you can show the student a lot of exercises, the student do the exercise by themselves, they write it down, and they can compare the answers after a while using the lever. It's really mechanical. It's quite ancient, but the idea is that you get instant feedback and that the student itself is has the liberty to be uh, conducting, leading his knowledge, building his knowledge as he does the exercise. So that's the first idea. Then we talk with technology. Technology is about allowing each student to be free to build his knowledge. And there is quite a interesting fact that we have here in Brazil a idiom barrier, a language barrier. We talk Portuguese. It's a beautiful language. I love it, but unfortunately, most technology use English, and we have a really low level of literacy in the English language. So we have to rely on technology that have a lot of information or documentation, as we are going to talk after, in Portuguese to really connect to the student. And then we have the last problem, I would say, that it's the infrastructure or the hardware part. Here in Brazil, we are just now getting to have a little bit, how could I put it, decent, not the best infrastructure, especially in fundamental education, in basic education. In higher ed, we have a little bit more infrastructure, but most of the time we have schools that don't have internet connection. Some of them don't even have computers or have computers that are really outdated. So we have to find a solution that can be as lightweight as possible. And also, I think that's really important that we talk about public policy about education and technology. I got this example from UK. Their national curriculum is quite, I think, that advanced in comparison with ours, the BNCC. And there is a topic that I would talk I would like to talk a little bit more, that their pupils, that I think that is children from 11 to 13 already have to have in their curriculum, at least they have to have used two or more programming languages, at least one of which is textual. And if we see the reality here in Brazil, we have sometimes this kind of situation where people are leaving university with the knowledge of one programming language, sometimes true, but it's difficult to say. So we are really behind in at this point, and I think that we have to think about restructuring a little bit of our curriculum to connect more to this reality. So what we can do about it? One of the resource that I would like to share with you guys to so that you can go deeper after this presentation is this presentation from Liam Calloway from Australia, where he shows a little bit of how his experience of using Python teaching math to higher ed. It's on YouTube. It's really easy to find, but the main idea is that it isn't difficult to connect mathematical and I would say any subject with technology and especially with Python. But I won't talk about Python especially now. I will talk about Logo. Logo was one of the first programming languages widely used and even mathematical tool. We have a lot of mathematical tool. I won't talk about GeoGebra and other subjects like that, but I think there are three subjects that aren't related to Python but are connected to maths and technology that we have to talk about. First, there is Logo that I think that it was 85 or 83 that it was developed, and it's really interesting that although it's quite a bit old technology, it's still used nowadays and has a lot of words in it. So you have a decent reference guides to show how to use it, and it's really easy to use to draw forms in it to create drawings that really makes the student understand how geometry works. And now I think that the most popular when we talk about programming language and mathematics is Scratch. Scratch is quite a little bit like Lego Mindstorm. It's a visual programming language. It uses blocks to create the algorithm that you execute. And I think that's one of the greatest tools to teach programming to children and to teach subjects, because you can connect the context of programming language with any subject. And also there is p5.js, that's a library for JavaScript that really creates a really interesting experience in using graphics most of the time. And also we have Sonic Pi, as I have said before. I think that is the best tool to connect math education and music. It's really kids love it. I have taught some classes using Sonic Pi, and everyone from basic education to higher ed think it's an amazing tool. But as the main subject of this talk, we are finally going to talk about Python. And why I think Python is the main object of my research, and why I think, and I think that you think also, is the one of the best tools to work with math education. Well, first of all, I think that we have three ways to use Python in the math education sector. We can use it as a powerful calculator. We will see that there are many modules to do that. We can use as a way to build educational apps. Uh, I have um, I have attended to the PyCon conference here from Brazil that's called Python Brazil a week ago. And one of the talks was a teacher that showed that she was able to teach Python from biology to chemistry, and it was really interesting because it was a matter of empowering the student. You know, the student can build something that they can use in real life. They really connect much more with the teacher and the subject itself when they build something that they see as useful. And I think that Python is one of the best platforms to build educational games, especially when we use Pygame. It's not really required, but it's one of the greatest tools to build games with Python. So, two books that I have to recommend also that are guiding my research is Amit Saha, Doing Math with Python. I think that it's the book technical book that it's better, has the better approach to use mathematical equations with Python, and math adventures with Python that I haven't really read it through already, but it's really interesting the experience that Peter Farrell shares in this book also. And other tool that I think that's interesting to talk about when we talk about math with Python is Python Tutor. Why? Because Python Tutor allows you to show how the inner workings of Python really execute your code. Like you can, it's an online tool that you can put your code there, and it will show you how the language process your code, how it builds variables, how it builds lists, how it do iterations. So it's a visual way to learn Python. So I think that's essential to everyone that's teaching Python, especially to younger kids. And we talked about logo, and one of the ideas is using the module turtle that implements the same structure as the logo language, but inside Python. So you can go from logo to another structures or even more complex structures in Python. That's one of the main things that I like about Python. You go from text-based programming to graphics with one or two modules or libraries, frameworks, as you call it. And so that is really one of the first tools that you can use. And you have a lot of built-in modules and libraries that do most of the functions that you need and equations in mathematical programming. One of the first is the math library. I think that it's the most it's the most resourceful one. It has factorial. It works with the greatest common divisor. It can round up or down a number. It also has constants like the pi, which is really used. So, like I said before, you can use Python as a calculator in a really powerful way. And if you need complex numbers, you have CMath with almost the same resource as the math module, but working with complex numbers. Also, in the basic toolkit from Python, we have itertools that also that works with permutations and combinations. Very interesting if you are working with discrete mathematics. And we have statistic module that has the some basic models. There are some advanced models that work with statistics, but if you need like mean and median, you don't have to input out the formula itself. You can utilize this structure from statistics module. And then Pygame, I think that Pygame is quite a game changer because it's an easy way to build complex games. One of the experience that I had using Pygaming as a teaching tool was building a simple snake game. But as you build the game, you see that there is much of math inbuilt in the code that structures the game. Like if you try to understand the game itself, it's like you have dots that will dislocate in a cardinal plane that we could say that they are vectors, and they have modules of like the basic of physics of movement. So the student is building a game that he has seen before, he understands it, but as he builds it, he really digs down mathematical the mathematical principles that make the game work, and he understands math as he understands the game. Another tool that, from my research, is being quite valuable is Anaconda. One of the problems that we have when we talk about Python is installing Python, the setup in Python for the first time, and Anaconda is a data science suite that really does it all, especially in Windows. Windows is almost 90% of users here in Brazil use Windows. So we can easily just have one package, one free software, one open software package that has everything that we need to use. Especially one, I think the last two of this talk is the Jupyter Notebook. Jupyter Notebook is one of the best tools that are available because it connects the idea that you can write the documentation itself, like write a little notebook, and imbue the code in the notebook itself. So it's one of the best tools that I have seen so far. And really it's interesting that you can make a combination that you explain what the code does, not only by commenting the code itself, but using images, using markdown language. So you really create a book with code, and it's an interactive book because the output of the code will be there also. And now the just to sum up, we have this ecosystem, I would say, of tools. So we can see by this image that Python itself is the base of scientific of ecosystem of scientific tools that really helps to create a deeper experience with math and with other areas. Like you need to plot a graphic, you have matplotlib, you have more scientific solutions with SciPy, with NumPy, and also others that I have talked about before. And also you have all the solutions that are already available. And the best thing about everything of this is that it's open source and it has the best documentation that you can have. So if you have any kind of doubt, you go deeper into the documentation. It doesn't cost a thing, and you understand what the developer that created this tool, what he wanted to do with it, what can it do. I think, and also we have a great community here in Brazil that translates most of this documentation. And finally, to thank everyone, I think that Ibrahimovic is the most famous Sweden person here that people know here in Brazil. And I couldn't end with a little homage to him. And I open to questions. I think that that's it for today. Slavik, I don't know if there are any questions on Slack or YouTube. I don't know
Thank
if
you.
if I have time, but that was it.
Thank you, Jerônimo. Thanks a lot for a lot of inspiring gags and clips, and for the overview of all the tools that are there in the Python infrastructure for teaching the math. I hope many of us will use those to teach students and to do their research. I have a couple of remarks here. I'm sorry about that. So
I
first of
understand
all,
you.
as
I
a
have a
board
picture.
member of PyCon Sweden, I certainly agree that Python is the best tool there on the market for teaching Python. And second, that studying math is the most essential part, one of the most essential parts to getting a job. We also, I guess, agree on that. And beyond that,
The audio.
sorry, can you hear me?
Now I can hear you. I think that's cutting a little bit of the audio sometimes, unfortunately.
We are separated. There is no Starlink satellite yet.
Yes.
Okay. There is a
We have a good infrastructure from networks, but not great.
yes, and we are also separated by an ocean. So there is a comment from Laura Wilson. For doing linear algebra, calculus, and other advanced
I think
things,
that cut again.
the Python package SymPy is great. And there is a question actually from Laura Wilson as well. Can you hear me, Jerônimo?
Okay, now I can hear you and I see his question. Can I answer it?
I will just read it aloud for everybody.
Oh, okay.
So, have you had the chance to teach students to use Python yourself? If so, how did it go? And there is a smile at the end.
Okay. I have a lot of experience with Python in short courses, and most people think like it's really easy to understand, to learn. Most of my experience is with technical students in higher ed. My main doubt is if we take Python to students in first in basic education here in Brazil, what's going to be their view. But what do I think about it? It's that it really makes things simple. It's keep it simple, stupid, like KISS. Just to get a little bit of it. Most of students we have here in Brazil have real big problems with programming, and we have here the teacher called Fernando Mansori or Masori that created a course called Python for Zombies, because he, in his experience, changing from Java to Python made the failing students go to from 30% to 70% of approval in programming subjects of science computation course. So I can't really talk bad about Python and education. I think it's really interesting.
Thank you, Jerônimo. And what do you think the
Is there any
appetite
more
in math?
questions? Is there time?
A short one, we will take it.
I think
What
that
do
I
you
have
think
the
the
audio.
appetite in math teachers to learn about Python?
Okay, the Joy Div question. Okay, what do you think about the appetite in math teachers to learn Python? It's really interesting because here in Brazil we have 70% of the teachers want and need to learn about technology, and they are eager. And even as my research go, I've dig down a bunch of papers from the last 10 years of teaching technology and teaching programming language, especially with math. And I think that most of the cases, the teachers, after they learn, they think that's awesome. But several of the studies shows that the first moment is something of definition. If you can't show that it's really a game changer, most of the time it doesn't work at all. And the stumbling block here in Brazil is the problem about the language. I think that most of the teachers and students have a really big problem with language. I think that we have to tackle the issue of programming language itself and about the language, as we say, the English language. Any more questions?
Okay.
And any more time?
Thanks a lot for your answers. Yes, we are slightly behind the schedule, but so there's going to be a short summary of today in the main track, and then please join us tomorrow at 9:30 with the next keynote. And thanks a lot, Jerônimo, and thanks a lot for everybody for watching this. See you tomorrow, and bye-bye.
Bye-bye.